Alright, so let's talk about the multi-threading and parallel programming. So what's multi-threading? So it enables multiple tasks in a program to be executed concurrently. So meaning at the same time. So let's look at.
Require a CPU that supports multi-threading?
That's a good question, right?
You can't multi-thread on computers that are old enough.
A program may consist of many tasks that can run concurrently. So a thread is the flow of execution from beginning to the end of the task. So let's say if I have a multiple CPUs, right? You know, some machine has multiple CPU, right? Like quad core, right? You could remember thread is comparing thread to an application has many tasks, right? And then you can have thread to control the flow of the execution for each task. Okay. So like thread is like a process that need to be executed. Let's say the task is Mr. A is going to have to be in the class, go to the school, right? Also, Mr. B also has to go to the school, right? Also, Mr. C has to go to the school, right? Now, if I have multiple cars, just like multiple CPUs, right? I could make car 1 to complete thread 1 to pick up Mr. A and drop at the school. Car 2 do the same time, pick up Mr. B, and car 3 pick up Mr. C, right? They can do it at the same time, correct? At the same time, at the same minute, at the same time they drop. I mean, we can finish all 3 tasks, which is quicker, right? But we can do with a single car too, right? Single CPU, right? By picking Mr. A and then drop him maybe in the middle of the way and say, hey, wait, and come back to pick Mr. B and drop him in the middle of the way, and come back, pick up Mr. C and drop him in the middle of the way, and now go back to pick up Mr. A and keep going to the middle of the way, right? Same as the rest until we get to destination. Same thing, right? So one CPU can complete multiple threads too, correct? By doing in different, right? Small tasks that we've done. Why we could do that? Because CPU is very quick. It's processed very quick, and you know, multiple threads share CPU time, known as time sharing. So OS is responsible for scheduling and allocating resources to them. And it's very idle that be able to do that, because most of the time CPU is idle. I mean, it doesn't do anything. Like if I enter something here, right? Do you think CPU is processing anything when I enter this? No, right? So you can monitor the CPU here, right?
You still have Cortana on?
You see, it's only, this is multiple tasks, right? This is many of them, right? Background processes. So it's running thread. This is concurrency, right? I have many applications running. I record the videos, right? So I have my browser open, serving.
Wait, I have a question. Why do you still use Cortana?
I didn't use Cortana. I just use a search.
Did you disable it? I had to go to root, and I had to root my computer to disable Cortana.
You like? Why?
Because Cortana sends whatever you search back to Microsoft.
Not Google. Google didn't do the same.
Cortana is Microsoft. It's Windows. It's owned by Windows.
I feel like Google does the same thing.
I'm sure Amazon also did the same. When you search something, they suggest you right away to buy something.
Oh, I see you're searching for Java code help. You know what would really do well? You need to buy some tea. Maybe this $300 book.
All right. So now this is called like concurrency, right? Now, how would you do that in Java? So in Java, they have a class called runnable. Actually, an interface called runnable. And each task is an instance of runnable interface and called runnable object. A thread is essentially an object that facilitates the execution of a task. So meaning you create class as a task, right? That you plan to do multi-threading. Can you give me an example? Of a class that pretty much your data structure, right? People is going to access to your list. You get a search at the same time if you publish that online, correct? So your list implements runnable, and then you pretty much has all the tags, right? And then you're gonna have the client, pretty much the main or whoever call it, right? Class to use. You must create a new instance of task, and then you're gonna have to run inside the threads. You pass this as an object of the threads, and then you do thread.start. So that's how you do the threads. So like for example, if you look at this program, right? So we have the task to print the characters, and we want it to be able to support the concurrency, right? Programming. So we implement runnable in this case. So meaning that the method print chart, right, that we want to call, this is a constructor, right? Actually you create an object, right? I want to print letter A 100 times, letter B 100 times. So when I hit run, I mean run is the main method to tell the system what task to perform. It's going to print the characters right away, which is run is going to be executed from thread.start, because you have to pass the runnable object to the thread, which is an object that implements runnable. And then when it starts, it's going to execute run. So this one has two classes. One is print num and one is print char, right? We should see print char. So it's going to run 3 different threads at the same time. So what happened like when we run this? So first, how many threads do we see here? Wrong. How many threads do we see here?
6.
Why 6? Huh? Why 6?
There should be 3.
3 wrong. It's 4.
Oh, one is controlling.
It's 4. Huh?
So one is controlling, and other 3 is right there, right? Just like that. Ah,
Is main a thread?
because the main one is.
There you go. That's another main one. You got it. It's running a program is another thread.
Yeah. Okay.
There are 4 threads, right?
That's a tricky question.
Should be on the test, right? Now, yes, right?
Yes.
Before it's not, right? So my question is, once you run this program, what should be the output now? That should be on the test too, right? After you executed this program, what should be the output? Anybody? We have A, B, and hundreds. 100 pretty much just print numbers 1 to 100, right? Okay. So what should be the output? Anyone? You see the code, right? So this could be the main. I'm going to create a new Java class. This is a client class, right? I think last time I found the source code for this. Did I share it to you?
The book? Yeah, we have it.
The source code for the book? Yeah?
Mm,
You know what? We can just Daniel. Okay, that's fine. Okay, let's just build it. That's fine. Just try to shorten the time, but it shouldn't take long either. So what's the output, do you think? I'll let you think until we finish, huh? What's the output?
There are gonna be like 4 different outputs. 3 different outputs.
AB1, AB2? Okay, any other options? Any other options? Everybody agree with that? And why could it be AB1? Why could it A and B? I don't understand why it's A and B. Why? What's the reason behind that? So you said it's gonna print as sequence A, B, and then 1, and then A, B, and 2, like that. Is it looping here? Do we have any loop doing that? Yeah, and why it would do that?
Because we set thread 1 as thread print A. And we started the thread 1 first.
So you said because
Yeah, there's a hint with those numbers, so you can do selection, column selection mode, and you can like delete the whole column of those numbers. Professor.
oh really?
Yeah, so you do, if you right click,
Uh-huh.
right click, Then you do this column selection mode. Yeah, it's the fifth one. The fifth.
Fifth one on the top.
Yeah.
One more down.
Yeah, this one. Then you can select the whole column. Yeah, go down. Yeah, select and go down. Yeah.
Oh.
Yeah. This is cool. It says selection. Select the column mode. So you can select the column.
Oh, instead of set a row. Very nice.
Yeah, hit a row.
Now you tell us.
This would have been like 4 months ago when I was trying to copy paste.
I mean, nobody asked me.
How do you do format again?
Delete. Highlight. Delete. Highlight. Delete. Highlight.
How do you do format again?
200 lines later.
Right click. Then the fifth one. Yeah, column selection.
Oh.
No, format. Format.
Format.
Oh, the hotkey for that is Alt Shift Insert.
Control Shift F or that one should-
I know, but
Control F.
hmm. I'll shift what? I it's not working.
Well, confusing.
You're looking for the codes. Just type it out. Just type it.
All right. So how to do format? Let me know.
We need that too. You're gonna tell us.
Again, we're still waiting for the answer, right? Because we are about to see the answers. Hmm.
You can, yeah, you have to drop that. So, this is
No one answered yet, huh? Only AB. So AB and 1 is not correct, okay? Look, this is the answer, right? If you rerun again, it's going to be different. See? Just like if I have to pick up Mr. A and Mr. B, Mr. C, we don't know who's going to get to destination first, depending on the traffic at that time, right? Make sense? So it happened at the same time. It's try to print A, B, and numbers at the same time. Make sense? So that means it could be any possible outcome, right? So if I put this statement, hello world, what do you think the output is going to be?
Is Hello World gonna be at the end?
Yeah,
Since it's not part of the
really? It's most likely it's going to be at the beginning. Because main thread is going to be finished before the rest. Because main thread only print once, the rest print 100 times. There are 4 threads, right?
Yeah.
Main thread is going to have another thread that will complete this, but it's still going to do itself too, because it's just the job is just to start those threads and then print hello world. Only 4 tasks here, right? But the rest is going to print 100 times. It's going to take longer than hello world. Make sense? So if I have this question at the test, you pretty much going to be, if you don't know this, you're going to say hello world at the end. Correct? Now you understand.
Yes.
Any questions? So now my question is, okay, what happens if I want main thread to wait until the other thread finish first before print hello world? How would I do?
Would you could start it last, or you could I don't know.
So that's why we have the methods.
Tell the thread 1 to not start until thread 2 and 3 stop. So can you check that?
We have the method from the threads doing those type of thing. There's so many methods, right? Because thread is a class, right? So we just make it join. So now it's gonna wait until those threads done and then say hello world. Join back to the main, right? All right, so we understand the basic of the threads now. Like I said, the thread class contains the constructor for creating the threads for tags and the method for controlling threads. Right, we use join to control the thread, right? Wait for this thread to be finished. Right, the thread to be finished. Start the thread. Is alive, test whether the thread is currently running. Set priority. Right, you can do priority, right, 1 to 10. Which one is having higher priority? We can do sleep for specific period of time in milliseconds. Cause a thread to pause when you use yield for temporary and allow other threads to execute. Interrupts the thread using interrupt. So since the thread class implements runnable, you could define a class that extends thread and implements the run method. So we can have another class extend the thread, right? That's another way instead of implements runnable, right? You can do extend thread and you can do the same. The thread class also contains the stop, suspend, and resume. As of Java 2, these methods were deprecated or outdated because they are known to be inherently unsafe. Instead of using stop, you should assign null to a thread variables to indicate that has stopped it. So let's look at how to use yield. So when we run to print, you can just make yield to that, right? The print num. So every time it's print, it's going to yield it to other threads. So let's see. So meaning that so we see number there, huh? Do you see the difference? Let's see without a yield first. So those are the numbers. 1, 2, 3, 4, 5, 6, 7, right? Let's try to put it under. What happened to print char? So it look like due to the number first, right? This one doesn't do that. Let's see one more time. Not always, huh? But looks like we have more number than the text. Last time is most likely the characters, right? Okay, we can do sleep. You can make a sleep for a period of time. So let's see if I wanted to sleep. Meaning that while sleeping, then the other threads will be performed. So let's make this sleep. So you could make it sleep for the 1 second, or this is 100 of 1000, like 1/10 seconds. Let's see. So most likely numbers should go first. See that, right? And this is slowing down, still printing, right? You can slow down the output too, it's still printing. Done. So it's required to surround with the try catch. Okay. Which is the interrupt exception, because it could get an interrupt, right? Most likely to happen when it slow down. So we talk about join, like we force main thread, right, to wait for the other threads 1, 2, 3 to be done, right, using join. It's like this is show another example. So we have thread 4 start, and it's going to print the characters, right? So it said when it's print to 50, you're gonna wait until pretty much wait for thread 4 to be finished, right? This is your main, right? So thread 4 is created and prints character C 40 times. The number from 50 to 100 are printed after thread 4 is finished. Java assigns every thread a priority. By default, a thread inherits the priority of the thread that spawned it. You can increase or decrease the priority of any thread by using the setPriority method. You know what? Let me test more join first before we look at that. So let's see. Now we understand that when we put join, meaning what? We wait until. So this say if I put thread 4 join, wait for thread 4 to finish, right? So same main thread here, wait for thread 1, 2, 3 to finish, right? So if can I actually try, we know thread 3 is doing the numbers, right? So if I put, let's do the sleep out first. So if I put the this is the number. If I say thread dot join, no, we cannot do that because it has to be instance, right? An object, right? It's not static. Unless you have multiple threads in here, right? You can refer to different threads. Okay. All right, so now let's look at set priority, right? So it's between 1 and 10. Min, norm, and max, those are 1, 5, and 10 consequently. So it says JVM always pick the currently runnable thread with the highest priority. A lower priority thread can run only when no higher priority threads are running. So if all the runnable threads have the equal priority, each is assigned an equal portion of CPU time in a circular queue. We understand queue in a circular queue, right? This is called round robin scheduling. So let's set the priority now. So let's see, we said thread 3 is the number thread, right? We set the priority to max. So it's supposed to make the number first, right? And let's set it to min.
The final exam next week is going to be at the same time, 4 p.m.
You can come at 2, remember?
But we didn't actually go over the.
So you see, all right. So that 3 is the numbers, right? Still do A and B, huh? Because start from A just start. Let's say so let's do this. If I do all the priority first before we start, right? Because it seems like start and then set later, that's why, right? So it seems like to allocate times for the characters. I mean, it's performed for the numbers. It's not much different, right? Oh, but it's different here, right? Before numbers mostly at the end, right? So when we set priority, it's allocate times more into numbers, right? Because max. A thread may never get a chance to run if there's always a high priority thread running or same priority thread that never yields. So we have this situation we call contention or starvation To avoid contention, the thread with high priority must periodically invoke the sleep or yield method to give a thread with a lower priority a chance to run. So this is not most likely to happen. What do you say, huh? So we set the numbers to be max and min. It looks like it's always not yielding it, right? Still, huh?
Did you make one of them with sleep?
The print name I took out already. Sleep I comment out already. I took out already. Not different, huh? Okay. So you can use the threads to make a flashing text. So let's look at the code. So I have the label called programming is fun, right? So this is JavaFX, right? Extends application. I want this text to set it into the pane. Now we create a thread. Then make runnable, implement it. Alright, so this is called what? Before we rewrite the program like threads, new thread, and pass in, right? Pass in the task, which is an object of runnable. And this has a class that implements the runnable. This is called, you create pretty much another class and object and pass in. But this one called anonymous. Anonymous means you don't want to specify the name, right? So give anonymous to the class. Like this one we specify print char, right? This one is anonymous because technically we're going to do it once, so that's why we just make it anonymous in the class. So this whole class pretty much implement inside, like we implement run in separate class here, right? But this whole thing just implement, we call an inner class, anonymous inner class. So we print run, implement run. So use a loop. Make it always true. So it's going to keep doing this because it's true. What does it do? So it's flashing text, right? So that's why it's just make text equal to nothing and equals to welcome. Getting the text from the label, right? When we see if the length of the text equal to 0, we can make text say welcome. Else, just make it empty. So that's why I keep looping this. Right? Sometimes say welcome, sometimes say empty, right? So you make a loop to repeat this. So let's think about if we don't use thread. Do you think we can see the text flashing?
Yeah.
Okay, if you say yeah, let's try. This is going to be new project, right?
do the while loop. Set it equal to welcome.
So we're gonna do the JavaFX, right? Application. Oh, not that one. Import JavaFX dot. All right, one is start.
Is it
Extends, yeah. One start, we gotta do what? Create a label equals new label. So hello. Spelling, huh? Alright, so how would you make this flashing text? We need to add this to panel, right? Let's just do flow pane equals to new flow pane, and then pane dot set. We want to add get children dot add the label. So this is just implement the GUI for JavaFX manually without fxml. And then how do you show? So we have this scene. We have to create a scene first in JavaFX. Equals to new scene. And we pass in the pane to the scene. And then we just do primary stage dot set scene to scene. And do primary stage dot show. This should give you the label. Now we talk about how do we do flashing label, right? Hello, right? Flashing label. You were saying that if I use loop, right? True. It will never reach that statement, huh?
why don't you just put the label dot set as inside the loop?
But I can't even make a loop yet.
Oh, it's at the start.
Set text.
Set string.
What did you try to say?
So if you make a loop and inside the loop you call the label and set your text up there and make it something
Okay, what is the loop conditions?
true, always true, so it can go.
But it will never reach this. You want to have it later? It will never get to that too, right?
Maybe you can make a method that calls that.
Huh?
Maybe you want to make a method that calls that. And
Same method is just something in between, right?
Is this where we use the new thread?
That's why we want to use the threads, right? Because it could happen at the same time. This is a main, right? Correct. So, okay, we gotta create a threads, right? Where would you create a thread? So if you look at this, is create a threads right after you add, like before the scene. Right? Why would we do that? Because you want to start, this is gonna be the main, this one thread, right? And then you want to start another thread, right? Right here, right? Okay. How will you create a thread? Equals to new, but you want to give the task right to the thread, right? Remember, if we create a thread, you have to put a task, right? Between a thread, right? What is a task? Correct? Like, you could create separate classes, right? But now we just make it in a new same class, right? Right, and in there we call anonymous inner class. Run. What do you want to do? While, so it's going to start a new task separately, right? Then it should be allowed because now this line is reachable, right? True. Okay. How would you make the flashing text? So it's a if the label dot get
Just like save the label, then
text.
delay, then like sleep for 2 seconds, then set it equal to nothing. Then the while gonna go first, then set the text equal to something, then delay.
Length. If the length equals to, in this case, if I want to do hello 0, then I don't want to initialize this, right? Then the length is gonna be 0, right? Then we go to label dot set text to hello. Else, that means it start to be not 0, right? Then we set text to nothing. Let's think. It's gonna keep checking. See 0 is gonna flash back, right? Okay, if we run this, you not gonna see it because we had to put the delay, right? Alright, so let's talk about delay first. Like, it could be very quick, right? Right? Program run very quick, right? So should the delay go here?
Inside the one.
You said it should be in the while loop. Where? Right here? That means it's not going to loop back. It's going to wait. Right. You said right there? Hmm. Okay. So it says right here. It's unreachable because true, right? It will never reach to this line. Okay. So it has to be inside the loop, right? Because outside the loop is not going to be reachable. But it has to deal with run later. What's that? You didn't talk about, oh, here, right? Here. Tell the system to run this runnable object in the application thread. Okay, so come back. Remember? There are two threads going on, right? Main thread, right? Main thread here, right? Right? And another thread, right? So this is a main, okay? And then main thread just happen to jump to call the flashing hello, right? And if you make it, would you make it flashing here or here? This is your main, right? And this is just the anonymous inner class that do the flashing, right? If, right? So if you set delay, it should delay in the loop. That's correct, right? But you want it to run back in the main application. You don't want it to run inside its own thread, right? Like if you make thread dot sleep so platform dot invoke like the set text should make it I think run later, right? It should set in the run later. Let's see, we're missing. So this is the lambda, but let's see original one. Runnable, right? And make the run, right? Run later. So pretty much you make another thread to run to set text. You don't want to set text in the same thread, right? Alright, so what we want to do, we want to set text right here. equals to this. So it doesn't see this text because in different class, this is two separate classes, right? This is in this is another class. So it has to make it global to this level. All right, so let's check again. See, in this case, we could say hello first here because we're going to initialize that to, let's say 0 here, huh? Okay, it says 0 here, then we go set text hello. Wait, 0. And then we said run later to set the text. We want to set the label. And then we sleep. Sleep should be inside the loop, right? We have inside the loop, right? Okay. So sleep in the loop. Label set later. And now we need to start a thread. We didn't start a thread, right? We have thread but never start. Thread. This thread. Okay, let's see if we can do start. Okay. So let's see if I just do the set without invoke later again, because we didn't start last time, right? It just stay, right? Because it's set, it's get to that event delay. It's just run this main thread and make delay. So that in this case, there are two threads, right? Main and this thread, right? It will come back. So this thread will run by itself, right? It will come back. I will set, just like set, but it looks like it should work, right? Because it should come back and set to empty and update the text to empty, right? And wait at that for another 2 seconds and do again. Now, the key is invoke later. or run later, right? In this case, we use run later. It happened in swing too. Run the thread at some unspecified time in the future. So most of the time that I see, if you don't put run later, you will see behavior is different. It say here, this method, which may be called from any thread, will post the runnable to an event queue and then return immediately to the caller. The runnables are executed in the order they are posted. A runnable passed into the run later method will be executed before any runnable pass into a subsequent call to run later. If this method is called after JavaFX runtime has been shut down, the call will be ignored. The runnable will not be executed and no exception will be thrown. And this is something that you want to avoid. You don't want to put too many runnables. Otherwise, application may become unresponsive. Applications are encouraged to batch up multiple operations into few run later calls. Additionally, long-running operations should be done on a background thread where possible, freeing up the JavaFX application thread for GUI operations. So that's the reason why we want to put the run later. To make it run in the main applications, not in this thread. Okay. Because if you don't put run later, it's going to run in the same thread, which will not affect the main application to flash. Make sense? Because the main application is here. Like when you run that, it never gets back to the main application. It's just run, and then remember the behavior is different. It's just flashing inside but never update the main application. Okay. I think this is something that you need to know about thread, right? Let's see. So does application do flashing? You can make a thread pools. Like a pool of threads. Synchronization is important concept too. Oops. So what's the thread synchronization? Let's say, for example, I have the list, right? And what happened, like this is an account, right? But let's say I want to update the balance. Like this one, let's say deposit, right? Think about, many of you will have a bank account, right? Once it's created.
If it's empty account.
Like million of account will be created, right? For Bank of America, right? And there's a method called deposit. Remember, this is a class that share among like million of objects, right? And this is a thread, right? Running, meaning it's concurrency. Do you think it's possible that you going to deposit the money as well as we going to deposit the money at the same time. V is a person name, right? So Will and V can deposit the money at the same time, or maybe some other people, right? So it's going to call the same method, right? You've been writing a program that use only one application, one thread, one user, but concurrency, that means you write a program to support at the same time. It's going to call deposit at the same time. What happens? The behaviors can be different. It's going to crash. So that's why we need to lock the method first, and let's finish this task one finish and then unlock it. So to do that, we just put a synchronized keywords in front of the method like that, like synchronize void deposit. So if an object using it, it's going to lock it and not letting the other object using it. Make sense? Like that. Okay. So you should use that a lot, like when you do like add elements to the list on your list, like because you don't want to add to be called, like we can add two elements to the list at the same time, so you should synchronize it. I think that's pretty much just the case study. The rest, semaphores can be used to restrict the number of threads that access a shared resources. I think the key thing is avoid the deadlocks. You can use the synchronize to do that. Okay, I think it's time, so I'll let you go